So let's start with analyzing and defining an analytical requirements. Analyzing and finding what's inside involve two pieces of the puzzle. First is the target feature that we're trying to find, and the other is the area that defines the area of interest. So let's start with talking about the kind of area we're dealing with. There's two kind of possibilities. One is that the area you're dealing with is just one single area that can be made of a number of different things. For example, it could be zip code, could be any of those administrative units like counties and states and populated places. Sometimes it could be just a manually defined area. For example, you can easily aggregate a number of townships and define that as your study area. And sometimes you just group small areas into a large area that becomes one. Okay. Anyway, those areas are treated as one. If you have that case, you may have to first define those, and that may take the steps. For example, you may have to clip, or you may have to aggregate, you may have to merge, okay, or dissolve multiple areas into one. We're now assuming that the area that we're dealing with is just one area. And the other possibility is that you have more than one area where you want to calculate the number of things for each of the many areas. So that's the two kind of categories we're going to deal with. In terms of the targeting feature that we want to select or find, there's also three possibilities. One is that the features may be point type, where it takes an address or location. For example, the crime occurrence or bird nest. So this kind of things tend to be modeled as a point. In case of point, we basically do a test of point in polygon kind of analysis. If a point is inside a polygon, we're going to count them in. The other possibility is that the feature take a linear form. For example, streams, roads, and pipelines, or telecommunication network. So these are taking the linear feature. When you deal with linear features in relation to area, there's more complication. So the lines could be totally within an area or could be partially within an area. So depending on what kind of result you're looking for, you may have to prepare the data or prepare the analysis in a very different way. And the third type of feature, we call it aerial feature. Okay? They are discrete objects, but each one of them have an area, they have a size. For example, land parcel. Okay, land parcel tend to have pretty significant size, and if you want to find out whether a land parcel is within or part of a floodplain, okay, then we're dealing with this question: what are the parcels or areas of residence belonging to this flood area? So these are the three kind of features. Each one of them required very different treatment. In order to choose the right methods, we also need to look at what kind of results you want to generate or report back to your boss. For example, your result could be something like finding out all the individual features inside an area, just report individual IDs, make a list. Okay, that's one type of report. The other type of report is to summarize or even sum some values of the features you find inside the area and report that number back. These are two different kind of decisions you have to make. And we're going to see that when we do this analysis, those are the decisions we have to make according to the situation. Map A on the slides shows that there is a floodplain colored as blue, and then there's parcels, okay? And one kind of result we want to find out is if a parcel I'm interested, for example, is my home floodplain, or if the house I'm going to buy part of this floodplain. Okay? So you're looking at a particular area, a particular parcel, and your answer is whether it's true or false. So that's pretty easy to do with the kind of tools we use. And the second question is you want to list all the parcels that is inside a particular floodplain. Okay, so you do not aggregate them, but you make a list. Okay? Here we see that there's a number of parcels are selected based on the flood area. Okay, and those can be used to report that. The third type of analytical result you can generate is to find all the features inside the area and then count how many of them are inside. For example, you can count how many land parcels are inside a floodplain. In that case, we can output just a single number. On the map, we show there's 79 parcels actually located within the floodplain. Another kind of result we need to generate is to summarize them by types. In this case, we can look at how many single-family parcel or multifamily parcel or agricultural land use, how many individual count of those types are located inside the floodplain. Those will give us some idea of what kind of resource we need to allocate for different sectors. The two more complicated case is that when we want to sum the value of the target feature and to generate a summary. So for example, in the map E, we have 79 parcels are inside the floodplain, and we can sum up the land value for all those parcels and generate one number. And the last case is we need to summarize the area of each of the land use type within the floodplain. We still need to generate sum, but the sum need to be generated with each of the subcategories of land parcel. We can sum all the features by their values, and then we can do this calculation by the land use type. Another complication for analyzing what's inside is to deal with the case when the target features are not completely inside, but is partially inside. And the way we deal with that can be different depending on your requirements. For example, if you try to find that all the roads inside a protected area, protected land, and you want to make sure the roads are in the kind of right construction. And in that case, you may have the application may require that the road must be completely inside so that the budget can cover all the construction. Or if the road is qualified for funding, even it's partially located inside the protected area, like the second case. Sometimes we could look at things like since maybe the area we have multiple pieces, as long as the linear feature are intersecting with any one of the component area, and they may be fine. But exactly which type is applicable to your case depends on the application. And also you use the parcels and floodplain as an example. If you try to choose only those parcels that are completely inside the floodplain, what you see is that the map on the bottom left, there's only 2 or 3 of those are meeting the criteria. But if you relax that requirement, say, okay, any parcels that are partially within the floodplain can be selected, then we have more. We have more parcels are qualified for that case. If we only limit the consideration to those elements that is part of the elements that's inside the target area, we have to clip or cut those features so that we have to drop those pieces of features outside the area so we can get some map like as clean as the third map on the bottom. Right? So you see the results is very different in terms of the output. In real application, you may have a hard time to determine or decide whether you should use a completely inside or partially inside. There's two general guidelines that can help. One is that if your results requires a count of a number of features within this area, the chances you probably use a partially within because you don't care whether there's any part of this inside or outside. You just want to know what is the number that impacted. Right? So that makes sense. And the second case is that you may need to know the actual amount, the quantity of the area or the value or the details measurements, okay? And then those areas are outside of the study area, even the partially within, we should exclude those, okay? In this case, we probably want to use completely inside, or we want to do the other things. We want to cut off those areas outside. In subsequent ArcGIS labs, we're going to talk about a number of techniques to produce that kind of results.